We're going to take a look at the sympathetic nervous system, neurotransmitters, and hormones in this lecture. The sympathetic nervous system uses norepinephrine as its neurotransmitter, and then the adrenal medulla releases epinephrine as its main hormone, along with a small amount of norepinephrine and a tiny amount of dopamine. Norepinephrine and epinephrine are going to bind to adrenergic receptors. So remember that the other names for norepinephrine and epinephrine are noradrenaline and adrenaline. So that's where the name adrenergic receptor came from. There's two different types of adrenergic receptors. We have alpha and beta adrenergic receptors, and there's a couple different subclasses. So you have like alpha 1 and alpha 2 adrenergic receptors. And then we have beta 1, beta 2, and beta 3 adrenergic receptors. All of the adrenergic receptors are G protein linked receptors. So they're all going to be metabotropic receptors. And they all use second messengers, so they're all going to go and activate an enzyme and produce second messengers. I'm not going to ask you which of the adrenergic receptors that norepinephrine binds to best and which one that epinephrine binds to best, so you don't need to memorize that. But on the sympathetic effector organs, we're going to find the adrenergic receptors. And most of the adrenergic receptors will be excitatory, although there are a few that are inhibitory. And then we'll draw a picture of this, but you can see on the target organs for the sympathetic nervous system, we have these adrenergic receptors here. So here's an adrenergic receptor. It's a G protein linked receptor or metabotropic receptor, and you can see that norepinephrine or epinephrine will bind to it. That'll activate the G protein. G protein will take off and will activate an enzyme, and then we'll make some second messengers, and then that will cause the response. And then this is just another picture just showing you the adrenergic receptors. We've got one over here, an alpha 2 adrenergic receptor, and then we've got a beta adrenergic receptor over here. So having either norepinephrine or epinephrine bind to either one of these, we activate the G protein, and the alpha 2 adrenergic receptor will inhibit this enzyme, and then the beta adrenergic receptor will activate the enzyme. And so that will either turn on or turn off the enzyme, and either you make or don't make the second messengers, and that will cause the response. You don't need to memorize this at all, so you can just look at it, but it just gives you all of the 5 types of adrenergic receptors, the alpha and beta adrenergic receptors, and where they're located in the body, which is interesting to look at. You don't need to memorize any of this, and I'm not going to ask you whether norepinephrine or epinephrine binds to it better. You don't have to know that either, and I'm not going to ask you either, what second messenger they make or whether they're excitatory or inhibitory. I won't ask you that either. All right, so one thing that is different from acetylcholine, the other neurotransmitter used by the autonomic nervous system, is that norepinephrine lasts longer than acetylcholine does. So it's going to take longer to get rid of norepinephrine at the synaptic cleft. And that's because we are going to reuptake norepinephrine into the presynaptic axon terminal there, and it'll get chewed up by the enzyme MAO. And then some of the norepinephrine will be chewed up in the synaptic cleft by the enzyme COMT. And then some of the norepinephrine will just diffuse out of the synaptic cleft and be taken away by the blood. And then it can circulate with the epinephrine that's been released by the adrenal medulla. So all of that is going to make the norepinephrine have longer lasting effects than the acetylcholine will. This picture just shows the 3 ways that we get rid of norepinephrine at the synaptic cleft. So one way is we can reuptake the norepinephrine back into the axon terminal of the preganglionic neuron, and it will get chewed up by the enzyme MAO, which is located on the surface of the mitochondria. And then we can also have some of the norepinephrine chewed up by the enzyme COMT, which is located in the synaptic cleft. And then some of the norepinephrine can diffuse out of the synaptic cleft and then be taken away by the blood and then join with the epinephrine that's been released by the adrenomedulla. All right, so just filling out our picture to complete this here. So we've already filled out where acetylcholine neurotransmitter is going to be released and which of the 2 cholinergic receptors that acetylcholine will bind to. And now we just need to finish up with the sympathetic nervous system up here on the top. And remember, the sympathetic postganglionic neuron is going to be releasing norepinephrine as its neurotransmitter to talk to the effector organ. And the receptor that is going to be on the effector organ is going to be an adrenergic receptor. So that is what norepinephrine will bind to. And epinephrine will also bind to these adrenergic receptors. And remember that epinephrine has been released by the adrenomedulla, and that's been stimulated by the sympathetic preganglionic neuron to release the epinephrine. So, oops. So I would definitely make sure you memorize which neurotransmitter is being released where and what receptors are being bound by these neurotransmitters. So that will definitely be on the test. And then this is just a summary of that picture, but I like pictures better, so I probably would practice drawing that one a couple times and then you would have all that down.